Welcome back to our discussion about solving trigonometric equations. And in this video, we are going to focus on solving trig equations that can be factored to separate different trig functions. So let's jump in. This is one of the easier techniques, and so I think that you'll find it fairly simple compared to some of the other things that we've done. We are looking in these examples to find the exact principal solution for each trigonometric equation. And remember, a principal solution is the same as finding all the solutions on one rotation of the unit circle. So from 0 to 2 pi, but not including the 2 pi. Okay, so in this strategy that we're going to focus on, we are going to notice that our equations have more than one trig function embedded in them, and we are going to try to separate those into separate factors. Okay, so that's the whole idea. First, you'll set that equation equal to 0. Then you will factor the resulting equation, and you're especially looking for a GCF here. Okay. Sometimes you'll have two binomial factors, but especially we're looking for a greatest common factor, and usually that will be a trig function. Then we'll set each factor equal to 0, and then isolate our trig function to solve for x. For these first examples, they're already going to be factored for us. So we don't have to set them equal to 0 because they're all set equal to 0. And they're already factored. So we're just going to pick up here in this C and D for our technique, and there's a reason for that. As we look at how to do these problems, then we can go into the more advanced problems where we have to do steps A and B. Okay, so since they're already factored, we're going to set each of these factors equal to 0. So I have a factor tangent of x minus 1 times cosine of x plus 1 is equal to 0. So I'm just going to set each of those equal to 0 and then isolate the trig function. So move this negative 1 to the right-hand side here, move this positive 1 to the right-hand side here. So we would end up with the tangent of x is equal to 1 and the cosine of x is equal to negative 1. So now we can use our knowledge of the unit circle to answer these questions. Which angles on the unit circle have a tangent of 1? And that is where the y and the x values are exactly the same. So that would be at pi over 4 and 5 pi over 4. And where's the cosine of x equal to negative 1? What angle on the unit circle has an x value that's negative 1? And you should say pi there. So that's all there is to this technique for this particular problem. We just express our solution set as those three angle measures. Okay, so let's do these next couple of examples. Taking this equation, 2 cosine of x plus the square root of 3 times 2 sine of x plus 1 equals 0. Let's take each of those factors and set them equal to 0. Now isolate the trig function. So in this case it's cosine of x, so we would subtract the square root of 3 and divide by 2. And in this case it's sine of x, so we would subtract a 1 and divide by 2. So we would end up here with cosine of x is equal to negative square root of 3 over 2, and sine of x is equal to negative 1/2. Now, thinking about our unit circle, which angles there have an x-coordinate of negative red 3 over 2? Okay, and so that's going to be 5 pi over 6 and 7 pi over 6 for this equation. And now let's think about this one. Sine of x is equal to negative 1/2. Which angles have a y-coordinate of negative 1/2? And that will be 7 pi over 6 and 11 pi over 6. Notice I have an overlap, right? I've got 5 pi over 6 and 7 pi over 6, 7 pi over 6 and 11 pi over 6. So I just consolidate that into a solution set of 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right? So for this example, I have cotangent of x times tangent of x minus 1 is equal to 0. And so let's set those factors equal to 0 and isolate the trig functions. Okay, so cotangent of x is equal to 0 and tangent of x minus 1 is equal to 0. Okay, so let's think about this. So this is already set equal to 0, this left-hand equation, but this right-hand equation will need to move the 1 to the right-hand side and make that tangent of x equals 1. When I've got a trig function that is cotangent, let's reciprocate that. So let's flip this upside down and make this tangent of x, and flip the 0 upside down and make that undefined. So where is the tangent of x undefined? And where is the tangent of x equal to 1? Tangent is y over x, so the tangent is going to be undefined where x is equal to 0, and that's going to be at pi over 2 and 3 pi over 2. And now where is the tangent of x equal to 1? And that will be at pi over 4 and 5 pi over 4. Okay, and so we can express our solution set as those 4 angles. So for these next examples, we may or may not need to set the equation equal to 0 to start with, but we're going to need to factor. And we are going to look especially for a greatest common factor in these cases. So let's take a look. In this first example, I have sine of x plus 2 times the sine of x times cosine of x is equal to 0. So it's already set equal to 0. I don't need to worry about that part. So let's look at these two things. I've got two things added together, and you notice that there is a sine of x in both of them. That means I will treat it like a greatest common factor and factor it out. If I factor it out of this first part, I'll just end up with a 1 remaining. And if I factor it out of the second part, I'll have a 2 cosine x. So I'll end up with 1 plus 2 cosine of x as one of my factors and sine of x as my other. And now it's just like what we did prior. We will take each of those factors, set them equal to 0. We will isolate the trig function, okay? And so for this one, we'll need to move the 1 to the other side and divide by 2. And then we will think about which angles on the unit circle will satisfy these conditions. Which angles have a sine of x equal to 0? Well, that will be at 0 and pi. And which angles have a cosine of x equal to -1/2, an x value that's equal to -1/2. And that will be at 2 pi over 3 and 4 pi over 3. And so we can just express those as our solution set. Now this middle example, notice that I don't have my equation set equal to 0, so I need to do that first. So let's move this tangent squared of x to the left-hand side, which means I will end up with something that looks like this. Tangent squared of x times cosine of x minus tangent squared of x is equal to 0. And notice that in both of these pieces, separated by this minus sign, I have a tangent squared of x. So I will treat that as my greatest common factor and factor it out. If I factor it out of this first piece, I'll have a cosine of x left. And if I factor out of the second piece, I'll have just 1 left. So I'll end up with tangent squared of x times cosine of x minus 1. And if you're ever worried that maybe you didn't do this quite right, think about mentally just distributing it through. Tangent squared of x times cosine of x does get me this term, and then tangent squared of x times -1 gives me this term. Okay, perfect. So now let's set each of those factors equal to 0, isolate the trig functions, and then find the angles that satisfy these conditions. Where is tangent of x equal to 0? Remember, tangent of x is equal to the y-coordinate divided by the x-coordinate, so where the y is equal to 0. And where is cosine of x equal to 1? Or which angles have an x-coordinate of 1? Okay, and so this will be at 0 and pi, and this one will be at just 0. And so we end up with a solution set of 0 and pi here. All right, last example. What's our GCF? You should be kind of figuring this out by now. Our GCF here will be cosine of x. So we're going to factor that out, and then what will be our other factor? Divide that cosine of x out of both pieces, and you should get cosine of x times 1 minus 2 sine of x is equal to 0. Okay, set each of those factors equal to 0 and isolate our trig function in the right-hand equation. So sine of x is equal to positive 1/2 and cosine of x is equal to 0. Where is the cosine of x equal to 0? That will be where we have x coordinates of 0 on the unit circle, which will be at pi over 2 and 3 pi over 2. Which angles have a y coordinate of 1/2? And that should be pi over 6 and 5 pi over 6. And so that will take care of the solution set for this trig equation. That wraps up this strategy. In our next strategy, we will discuss how do we solve trig equations when there are more than one trig function in the equation, but it does not factor. So we'll do something a little bit different there, and I will see you then.